These are some sample questions just like the ones that will be on your quiz. So let's give them a try and then we'll go over the answers. So the first one, you're given a pyramid. It's a square base pyramid and you're trying to find, first part is you're trying to find bx. Let me show you where that is. It's right there. Now in order to find that, what we can do is find the complete diagonal BD and then just cut it in half, because that center point of the base of the pyramid cuts those diagonals in half. Now to find that red line, notice we're working with a square base pyramid, so each edge of the base is 12. So what you have here, that red thing which I'm outlining, is a right triangle. There's the right angle. It doesn't look like it because it's drawn at perspective. So to find DB or BD, we're going to use the Pythagorean theorem. So 12 squared plus 12 squared equals DB or BD squared. 12 squared is 288 equals DB squared. So DB equals the square root of 288. And you can use your calculator to get some values here. But what we're actually interested in is not dB. We're interested in finding bx, which is half of dB. So bx, before I go to my calculator, is going to equal 1/2 the square root of 288. So let's punch that in and see what that equals. And I'm getting 8.49 to 3 sig figs. 8.49. So that's your answer to A. Alright, so now that we know that's 8.49, let me erase some of this stuff on the pyramid. Now we're trying to find part B. We're trying to find angle XBY. XBY is this little angle right there. Well, if you notice, this edge, BX, and that altitude of the pyramid make up a right triangle. Well, we know that BY is 15 because all those edges going up to the pyramid's point at the top are the same length, so that's 15. We just found BX from part A. It was 8.49. So we can use a trig function in order to find this angle. Again, you're looking at this 3D image, so it's a little tricky to see, but BX, that bottom edge, is the adjacent side to that angle that we're after. And YB, the one I've got labeled as 15 in red, is the hypotenuse. So we've got the adjacent or the hypotenuse, which is cosine. So we know that the cosine of angle XBY is equal to adjacent, which is 8.49, over the hypotenuse, which is 15. And you're looking for the angle. Whenever you're doing that, be sure to use inverse cosine or second cosine on your calculator. So just go second cosine, previous answer, and I just leave that on my calculator. I don't use the rounded answer, 8.49. I just go up and grab 8.48528, etc. So that divided by 15, and I'm getting 55.55, or rounded off, that'd be 55.6 degrees. And there's the solution to the pyramid problem. So let's move on to the second one. This time we have a rectangular prism, and we're looking for several things. Let's take a look at this rectangular prism. We see that the front edge is 10, therefore we know the back edge is 10. The height is 6. The depth is 4. So the first thing we're looking for is PX. Let me show you where that is. It's right there. So what I'm going to do is think about that. If you notice, there's a little triangle, and that's a right triangle again because that's a rectangular prism, which means it's a rectangle on the base. There's your right angle. And that x point cuts the front edge in half, so this is 5. SP is going to be the same as RQ. The edges going back are 4. So again, we just use the Pythagorean theorem and we can find px. So we know that px squared equals 4 squared plus 5 squared, which is 16 plus 25, which is 41. So px squared equals 41. Px equals the square root of 41. I'm just going to leave it like that for now. Oh, I guess I can go ahead and punch it in and see what the decimal equivalent is. And that is 6.40. 3 sig figs, 6.40. Okay, next, angle AXP. Let me get some of this stuff out of here so you can see that angle a little bit better. A to X to P, which is that angle. Now if we take that back edge, there's our right triangle. The right angle's back at P. We know that edge going straight up and down. AP is 6. We know that PX, which we just found, was 6.40. Looking for this angle down in the corner. Again, we have the adjacent, but 6 is not the hypotenuse. That is the opposite. So we have adjacent over opposite, which is tangent. So the tan of angle AXP equals opposite, which is 6, over adjacent, which is 6.40, but I'm going to use my non-rounded answer so that I don't affect my accuracy. And hit inverse tan of 6 divided by root 41. Let's see what we get. And I am getting 43.1 degrees. Okay, those two parts are done. Let's go on to part C. Clean this up a little bit. Need a little thinner stylus here. Okay, part C, PY. Let's see where PY. PY goes from here to there. Okay, let me draw in where the right triangle is that we're going to use, which is that one. There's our right angle back in the corner. This right side is 4, so Y cuts that in half. This little section is 2. The back edge, PQ, is 10. It's the same as the front edge. We're looking for the hypotenuse, which is PY. So it's going to be 10 squared plus 2 squared equals PY squared. I don't know why this didn't want to write most of the time. There we go. So that's 104 equals PY squared. So PY equals the square root of 104, which is probably 10.1. Let me punch it in and see. 10.2, round it off. Okay, there's our PY. Equals. Okay, now angle AYP. AYP. From this top corner down to Y over to P. So it's this angle in there. Let me get some of these numbers out of here to avoid confusion. And let me go over the triangle we're going to be using, and I'll take out those other red lines. There we go. So AYP, we're dealing with this right triangle. And let's think about what we know. Well, we just found that PY is 10.2 rounded off. So let me label that 10.2. We know that AP in the back is the same as the other height, which is 6. Looking for that angle? There we go. Opposite, adjacent, inverse tan. So we got the inverse tan. Come on. Of 6 over 10.2. And again, I'm not going to use that rounded answer. I'll use the square root of 104. So the inverse tan is 6 divided by Square root of 104 is 30.5. Done. Equals 30.5 degrees. Okay. Now let's go to a trig word problem. This is where you just want to draw an accurate sketch to match the situation. So we have two men on the same side of a tall building. So here's our building. Two men. There's one. And here's the other one. Now they look up at the top of the building, up to the top of the building. And that angle of elevation, remember, is always down here from the line of sight up. So it's down at the bottom. So the closer guy is going to have the bigger angle of 60 degrees. And the other guy, further away, his angle will be smaller. So that one is 30 degrees. This says the height of the building is 50. Find the distance between the two men. Well, let's just break this down into two triangles. There's the blue one. We'll do that one first. Well, if we're looking for the distance between the two men, what we want to find is the distance to each man, and then subtract those two distances, and we'll have the distance between them. So, to find that x, let's look at our picture. We got 60 the angle, 50 the height of the building, x is down at the bottom, so inverse, not inverse tan, but tan of 60 equals opposite of 50 over the base x, the adjacent. Remember, when the variable's on the bottom, you're going to divide, so it's 50 divided by tan 60. Just go to your calculator, punch that in. And we get 28.9. So that's the distance to the first guy, 28.9. Now we're going to find the distance to the second guy. In other words, I'm going to find this red distance across the bottom. I'll call that y. So just focus on the red triangle. 30 degrees, the height of the building is still the same, so the tan of 30 equals opposite, 50, over adjacent y. That's a y. The variable's on the bottom, so we're going to divide, so it's 50 divided by tan 30. And my marker doesn't want to cooperate. Here we go. 50 divided by tan 30 is 86.6. So that's the distance to y, along y, to the second man. So we just take those two and subtract them. 86.6 minus the other answer of 28.9. Again, I'm not going to use my rounded answers. I'm using the original answers on the calculator. 57.7 will be the distance between the two men, and that is meters. Okay. And the last type of problem is areas of triangles. Remember the formula that we learned yesterday? Let me erase some of this stuff off of here. That the area of a triangle can be found by using the formula 1/2 AB sine C. Now remember, A and B are the two sides that form angle C. In other words, angle C is called the included angle. It's the angle between the two sides that are given. So in this case, 6 is over here, 8 is down at the bottom. Now 6 and 8 do not include 110, nor do they include 50. What they include is this angle down here. So that's the angle we need in order to find the area of the triangle. Well, that's not that tough because 110 is this angle, 50 is that angle. That adds up to 160. You know the sum of the angles of a triangle is 180. So this angle has to be 20 degrees. So now we can use a formula that area is 1/2 AB, or 1/2 of 8 times 6 times the sine of 20. And it's as simple as punching that in. These are pretty easy problems. So 1/2 times 8 times 6 times the sine of 20 degrees equals 8.21 square meters, centimeters, whatever the units happen to be. And that's the end of the sample problems.